Welcome back. Now we're going to be continuing with causation and correlation. In this video, we will be looking at the difference between the causation and correlation. Causation is something where one action causes the other, like smoking causes lung cancer. Correlation is a relationship between the change in one variable affecting the change in the other variable. Like smoking, there's a correlation between smoking and alcoholism. Smokers usually tend to drink alcohol, but smoking doesn't cause alcoholism, where smoking causes lung cancer or running causes weight loss. It is very easy to prove a correlation because it depends on the data and the math, but it's very hard to prove causation because something is causing another and there is no direct variable or data that we can look at. Now, let's go ahead and take a look at the examples of correlation and causation. So correlation is not causation, as you can see. In summer, usually people buy more ice creams. In summer, people have more shark attacks. But is there a correlation between them? No, there's a causation. Summer causes increase of sales in ice cream. Summer causes increase of shark attacks. Now let's take a look at the next one here. So just now, this is exactly what happened. I ran out of my battery and my computer shut down. So the running out of battery caused my computer to shut down, and the running out of battery caused my video player to completely stop. And I'm worried it might happen now as well. So, but is there a correlation between both of them? That's a whole different story. Now let's go ahead. One last example. As you can see, smoking causes lung cancer. Causation, smoking and alcoholism correlated. Let's look at the first example. The more mangoes you eat, the more rashes you get. True or false? What kind of question is that? I don't get any rashes. So this is depends on people and it's very subjective, and we did not take a lot of variables into consideration. So this is a false statement. Let's look at the next one. The more samples taken in scientific study, the longer the amount of time it takes to complete the research on the samples. Well, I don't need any causation correlation. This is a basic common sense. The more samples I have, by default, the more time it takes. So this is true. Now let's look at the next one. A large observational study asked participants about caffeine consumption on sleep duration. The study finds that people with large caffeine intake have shorter sleep duration. So they asked people about the survey about what happened, and they said the more caffeine they take, the larger caffeine intake have shortest sleep duration. So that's the survey. Now, based on this survey only, identify the relationship between, they're asking us to identify the relationship between caffeine consumption and sleep duration. They're not asking us to say anything or make a statement. They said, based on this survey, what is the relationship? Caffeine consumption and sleep duration are correlated. So that's a relationship, right? An increase in caffeine consumption causes, it's not a causation. So, and I don't know what it causes because causation is hard to prove. A decrease in sleep duration causes an increase in caffeine. I still don't know. Decrease in sleep, just because I'm not sleeping doesn't mean I'm drinking more coffee. There could be various other reasons or factors. And there is no relationship between caffeine consumption and sleep duration. No, the study did prove that people who take more caffeine sleep less. Let's take a look at the next one. The business finds that the sale increases when the outdoor temperature decreases. So the sales increase when the temperature decreases. So let me go ahead and show that to you in a graph. The temperature is, so the sale is increasing. When it's low temperature, more sales. As the temperature increases, the sales are decreasing. So if you see that, it's a negative slope. Usually when students see the word increase, they tend to think it's a positive slope. But remember, temperature is always on your x-axis. Temperature is independent and your sale is dependent on temperature. So in the other words, as temperature increases, the sales decrease. So it's a negative correlated. The larger the number of cavities, the older the people. What? No, even little kids have cavities if they eat a lot of candy. So this is a false statement. And that brings us to the end of this semester. I hope you understood this one. If you have any questions, leave a comment below in the comment box or email me or text me. Good luck. Can you believe semester is almost done? Wow.